Hello and welcome to YourPedia. My name is Aman Sharma and I am your mentor for CSC at YourPedia. So today's video is regarding generating functions. So as we have talked to many students who have gone through DRDO interviews in the recent interviews that are going on. So the panelists are asking a lot of questions in mathematics, and generating function is one of the most important topics, and they have been asking the question regarding the generating function. Now the problem with generating function is that you will not find enough material in the books or anywhere on the internet to properly solve generating function, or what is the you can say algorithm, or what is the procedure that you can follow to solve each and every kind of generating function. So today we will be covering that in our video. So first of all, we will see what is generating function and how we come to the formula that is being used in the generating function and in the chocolate property. Sorry. After that, we will be taking some generating functions and we will be seeing what will be the series or sequences that are associated with those generating functions. Normally they are asking what? They will be giving you a generating function and they will ask you what will be the sequence that will be made using this generating function. So let's start. So first of all, what is generating function? How do we solve generating functions? So let's say that you have a question x1 plus x2 plus x3 is equal to 10, and the constraints for x1 is 0 to 6 and 1 to 4 for x2 and 2 to 5 for x3. Now you cannot directly apply the chocolate property because you cannot satisfy the condition that you can take value 0 for x1, 0 for x2 and 10 for x1. You cannot do that. If you cannot do for all the three constraints, then you can say that you cannot apply the chocolate property on this one. So what we will be doing is we will be applying the generating function in order to solve this. Now the constraints, let's first correct the constraints. So 0 to 6, so we need this also, this and this from 0 also from 0. So what we will be doing here is we will be adjusting the constraint. So how to adjust the constraint? 0 to 6 here. Now if I subtract 1 from x2, what I will be doing is constraint will be 0 to 3 and 10 minus 1 here, because I have subtracted 1 here, and for this we will be subtracting 2. So 0 to 3 for this one also, minus 2, so the constraint will be equal to 7. Now this is our question that we have to solve. Now we can apply generating function on this one. Now let's try to solve this. Now for x1, 0 to 6 is the constraint for x2, 0 to 3 is the constraint for x3, 0 to 3 is the constraint. If you want to write it down, you can write these constraints as x0, x1, x2 up to x6. This is for x1. Constraint is from 0 to 6, so we are putting values of x raised to power 0 to x raised to power 6. And in the multiplication we will have x0, x1 up to x3, and similarly for the 0, 1 and up to x3 will be equal to 7. So this is the way of opening this and applying the generating function. Now first of all, this is a GP x0 to x6. If you apply the sum of GP formula, you will get 1 minus x raised to power 7 divided by 1 minus x. For this you will get 1 minus x4 divided by 1 minus x. For this you will again get 1 minus x4 divided by 1 minus x equal to 7. So this is a GP formula, and if you combine this, you will get 1 minus x7 into 1 minus x4 raised to power 2 divided by 1 minus x whole cube equal to 7. Now the solution to this problem, the solution to the original problem will be coefficient of x raised to power 7. Coefficient of x raised to power 7 in this. So if you could find the coefficient of x raised to power 7 in this, then you can find the solutions for x1 plus x2 plus x3, the number of different solutions possible for x1 plus x2 plus x3 equal to 10. So we need to find the coefficient of x raised to power 7 in this. Now there is a formula that we use in this. In order to solve this, we use the formula. Now, for 1 by 1 minus x raised to power n, the opening is r equal to 0 to infinity n minus 1 plus RCR and x raised to power r. This is a very important formula, and we also use it in chocolate property. So this is the formula that we will be using in order to handle 1 by 1 minus x raised to power q. So let's say we will write it down, 1 minus x7 into 1 minus x4 whole square, and here n is equal to 3. So we will get nothing but 3 minus 1 plus RCR x raised to power r. And if you want to solve it further, you will get 2 plus r CR x raised to power r. So this is the opening, and you have to find the coefficient of x raised to power 7 in this whole term. Now if I expand this, 1 minus x raised to power 7 will be simply put 1 plus x raised to power 8 minus 2x raised to power 4. And if I multiply this 1 to 1, yes, we will get 1. Now x8 will not give us anything, because when you multiply x8, r cannot be negative. So you cannot multiply something with x8 and expect the term to give x raised to power 7. So we will not be using this. So why write it down? So we will remove this in order to reduce our calculation. So 1 minus x raised to power 7 and into 1 minus 2x raised to power 4. So we will get 1 minus 2x raised to power 4 minus x raised to power 7 plus 2x raised to power 11. So this will not be, we will not be using again. So into 2 plus RCR x raised to power r equal to 7. Now if you solve this, when you multiply this with this one, we will be using different colors for these. So when you multiplying this with 1, the power of x in this is 0. So from here the power of x, if you want to make x raised to power 7, r should be equal to 7, then only x raised to power 7 into x raised to power 0 will give you x raised to power 7. So the value of r will be 7. So if value of r is 7, then you can solve it when it will be multiplied with this. So it is 7, so 7 plus 2 c 7, which will be equal to 9c7. So 9c7 for the first term. For the second term, you have x raised to power 4 already here. Now you need x raised to power 3. So r value will be 3 for this case, and the coefficient will be minus 2, and value of r will be equal to 3. So 5c3. So 2 into 5c3 for this one, and for this one we will use black. So minus x raised to power 7. So x raised to power 7 is already there, so the value of r will be equal to 0 here. So when the value of r is 0, you will simply get minus r is 0, so 2c0. And if you solve this, you will get answer as 15. So there are 15 different solutions for this equation. If x1 plus x2 plus x3 is equal to 10, and these are the constraints, then there are 15 different solutions for this equation. So this is how you apply generating function, and this is the application, or you can say this is how you solve any question which will be having constraint irregularities using generating function. Now let's move on. So this is a basic method, but in exam or interview you will be you need to have a good grasp of this concept, so that you can apply the more advanced method here. So let's say you have a question here. So we will be trying a question first. So the question is, you have 400 identical pens. You have 400 identical pens, and you want to divide them in packages of 5. So in the set of 5, you want to divide them in 4 student groups. Minimum amount a person should get is 5 pens, and maximum amount a student should get is 25 pence. So how will you make a generating function for this one, so which can properly depict the problem given in our question? So let's say now so 400 pens are there in total. So we have 400 pens and we have 4 students A, B, C, D. 4 students are there and you have to divide 400 pens among them. And when you are dividing 400 pens among them, minimum is 5, maximum is 25, and the pens should be given in the sets of 5 each. So the constraints, logically the constraints would be 5, 10, 15, 20 and 25, and for all these the constraints will be same. Now if you apply, if you remember the how we solve the generating function, so what we did there was, so we will take the constraints only 15 and x raised to power 25. So this is for A. Similarly for B, for C, for D, so there will be power of 4 here will be equal to 400. Now you have to divide 400 pens. So you have to divide 400 pens among the students. So the solution, in how many ways the 400 pens can be divided? So the solution will be coefficient of x raised to power 400 in this equation. So this is a generating function, or you can say this is a function, and the solution will be coefficient of x raised to power 400 in this problem. Now let's say that let's try to solve another problem here. Now the next problem we can solve here is, so it is saying that find the coefficient of x raised to power 7 in 1 plus x square plus x cube up to so on into 4. Now one thing that you need to understand first is 1 plus x square plus x cube and so on is the opening of which generating function? 1 minus 1x. 1 divided by 1 minus x. So the expansion for this is 1 plus x2. We will be studying this further, how this is a expansion and what will be the sequence for this one. So right now you just need to use this. So this is the expansion. Now there is a power 4 up to it. So the question is nothing but find the coefficient of x raised to power 7 in this. Now this is the type of problem 1 by 1 minus x raised to power n. So the solution for this problem will be nothing but n minus 1 plus RCR and x raised to power r. So n is equal to 4. So 4 minus 1 is 3 plus RCR x raised to power r, and we have to find what? We have to find the coefficient of x raised to power 7 in this. So if we have to find the coefficient of x raised to power 7 in this, so the value of r will be equal to 7. So the answer will be equal to 7 plus 3, 10, 10c, 7 will be the answer to this solution. So this is our question. So let's try something, some other question. Now the next we want to try is, now the next question is, we have to find the generating function for this one. A plus B plus C plus D is equal to 5, and the constraints given to you are all A, B and C and D are less than equal to 5 and greater than equal to 0. So these are the constraints given to you, and it is asking you the generating function, or you can say solution to this problem. Now simply the generating function for this one would be, now if the constraints are from 0 to 5 for all A, B, C and D, so these are 0 to 5, so it will be x raised to power 0 plus x raised to power 1 plus x raised to power 2, 3, 4 and 5, and all have similar constraints, so it will be nothing but raised to power 4 and will be equal to 5. So this is the function for this one. And if someone asks what is the solution to this problem, what is the solution to this problem, so the solution to this problem is nothing but coefficient of x raised to power 5 in x raised to power 0, x raised to power 1 up to x raised to power 5 raised to power 4. So you find nothing but coefficient of x raised to power 5 in this, you expand this, you find the coefficient of x raised to power 5 in this, that will be equal to the number of solutions of this problem. So this is how you apply generating function in normal the problem that has been asked to you. And let's say that if you want to solve this further, we can also do that. So if you want to solve this further, nothing but just expand this, this is a GP, x raised to power 0 plus x raised to power 1 up to x raised to power 5. So the sum of this GP will nothing be what? 1 minus x up to raised to power 4. So you can eliminate, you can take this to the, so 1 minus x raised to power 4, and this is nothing but, again 1 by 1 minus x raised to power n, the expansion of this is nothing but n is equal to 4, so 3 plus RCR x raised to power r, and you can expand this now. Now let's expand this one, 1 by 1 minus x raised to power 4. I can write this as 1 minus x raised to power 6 square into 1 minus x raised to power 6 square, and if I open this, it will give me 1 minus x, 1 plus x12, this will give me 1 plus x12 minus 2x6 whole square, minus 2x6 whole square. Now what we have to find here is, we have to find the coefficient of x raised to power 5. Now this term will never give you x raised to power 5, and this term will also never give you x raised to power 5. So the only term that will give you x raised to power 5 is only 1. So you ignore these two and you just write 1 raised to power 2, and the remaining function that we have calculated is 3 plus RCR XR. So you have to find the coefficient of x raised to power 5. So there is no x term here. So the value of r will be nothing but 5. So the answer you will get is 3 plus 5, 8. 8C. 5 will be the solution to this problem. So the number of solutions for this one will be 8C. 5. So this is your correct answer. Now let's move on to the sequences. Now how the sequence works, how you can find the sequences for generating function. So here I will write the generating function. Here I will write the numeric value, and here I will write the sequence. So there are some methods to it. So first of all, the first basic generating function is 1 by 1 minus x. So the numeric value for this is 1, and the sequence generated by this is 1 1 1 1 1 1 1, and so on. So the x, if you want to write the expansion of this is 1 plus x 1 plus x2 up to so on. Now if I change it a little bit, you can write it as 1 by 1 minus x. You can write it as this, 1 minus x. Now it will behave as 1 minus x. So the term inside the bracket is minus 6. So the expansion will be 1 minus 6 plus x square minus x cube plus x4 minus x5 up to so on, because whenever the power is odd, minus will the negative value will remain negative. When the value is even, the power is even, the negative value will change to positive value, and the numeric value is 1 minus 1 raised to power r, and the sequence generated will be 1 minus 1 1 minus 1, and so on. Now let's move on to the next one. So the next function is 1 minus ax. Now if you do this, you will get what? The ax plus a square x square plus a cube x cube and so on, and the numeric value is ar, and the sequence will be 1a square a cube a4 and so on, because all the x will behave as 1 and the coefficients will be present in the sequence, and the coefficient will be a square, a cube, and so on. And if you do 1 plus ax, this will be nothing but 1 minus a. So the numeric value will be 1 minus a square minus a cube, a4 minus a5, and so on. Now if we move further here, there are some different constraints that you need to keep in mind. Now let's say that in the question it is saying that 1 minus x raised to power k, 1 minus x raised to power k, not 1 minus x whole k, x raised to power k only. So what's the constraints here? You have to, now for normal 1 minus x, the sequence is 1 1 1 1 1, but for when the value of k is there, you have to put k minus 1 zeros in between each one. So for example, if it is 1 minus x cube, so the sequence will be 1 comma 0 0 comma 1 comma 0 0 comma 1 comma 0 0 comma 1 comma 0 0, and so on. Let's say that if you do 1 minus x square, so it will be 1, and you have to add 2 minus 1, that is equal to 1 0 each time. So 1 0 1 0 1 0 1 0, and so on. So this is the constraint here. So let's go over the sequence once more, so that you can get a clear understanding. So 1 by 1 minus x will give you 1 1 1, and so on. Now when you multiply any term with x, it will give you 1 0. I will show you x y 1 minus x. So 1 by 1 minus x will give you 1 1 1, and so on, and the x that is being multiplied here will give you 1 0 at the start. So let's say that it is x square 1 minus 1x. So for 1 by 1 minus x, the normal sequence will be 1 by 1 1 1 1 1, and for the x square, 2 zeros will come in the starting. Now let's say we will do 2 by 1 minus x. Now it is, you can write it as 2 by 1 minus x. So it is nothing but 2 into sequence of 1 1 1 1 1. So the sequence generated by this will be 2 2 2 2 2, and so on. Now let's say I do 1 by 1 minus 3x. It is nothing but 1 by 1 minus ax. So the term here, the sequence will be 1, 3 raised to power 1, 3 raised to power 2, 3 raised to power 3, and so on. We have done this already, it is nothing new. But let's say if I do 3 by 1 minus 3x. Now what it is doing is 3 into 1 by 1 minus x. Sorry, 1 by 1 minus 3x. So the sequence for this will be 1, 3, 9, 27, and so on. But when you multiply this with 3, the sequence will not start from 1, it will start from 3. So this is how a little change in the generating function. For this, the generating function was 1, 3, 9, 27. But if you do this little change, the sequence will be 3, 9, 27, 81. Let's say that you do a little change here. You put 3x 1 minus 3x. Now how you solve this? First let's say 3x here, and the sequence generated will be 1, 3, 9, 27, and so on. By this 3, the sequence will be 3, 9, 27, 81, and so on. Now this is x. What x does? You will put 1 0 at the start. So the sequence will be 0, 3, 9, 27, 81. Now we have seen three things here. For the initial sequence, when the relation this was 3, 9, 27, 81, and so on. The generating function was 1 minus 3x. When you put for 1, 3, 9, 27, 81, the generating function was 1 minus 3x. For simple 3, 9, 27, 81, and so on, the generating function came out to be 3 by 1 minus 3x, and if you do this 0, 3, 9, 81, 27, 81 and so on. So the generating function came out to be 3x over 1 minus 3x. So this is how generating function changes as you apply more functions into it. Now we will be doing some more examples of the generating function. Now let's say that you have generating function 1 by 1 minus x square. Now 1 by 1 minus x square is nothing but you will put 1 0 in the between two consecutive ones and so on. Now let's say you do this. You multiply this 1 by 1 minus x square by x. So x will do nothing but put 0 at the start. Puts 1 0 at the and so on. Now let's say you do x square by 1 minus x square. When you do x square by 1 minus x square, it will put 2 zeros at the starting and rest will remain same. Now we will try some different variety of generating functions. So now the next is 1 by 1 minus x whole square. Now in this case, when there is whole square here, it will give you, so first we will just do 1 by 1 minus x, which will equal to 1 1 1 1 1. When you do 1 by 1 minus x whole square, it will give you r, the numeric value r, and r will range from 0 to infinity. So the sequence will be 1 2 3 4 5 6 and so on. 1 by 1 minus x square. Now let's say that you put x here. So it will start from 0, 4, 5, 6 and so on. Now after that, let's say you want to, instead of r, numeric value r, you want to go for r square, which is equal to square of natural number, 1 square, 2 square, 3 square. So do nothing, we will do nothing but so. You can see the pattern here. When there is no power on x, it is simply but 1 1 1 1 1. When you increase the power, it is 1 2 3 4 5. When you increase the power by one more, you will get 1 square, 2 square, 3 square, 4 square and 5 square up to so on. But there is one thing that you need to add before doing that. Now in every case, when you are doing 1 minus x raised to power, let's say m, and you want to generate a for 3 the power was 2, so you want to generate r m minus 1, because for 3 the power was 1 square, 2 square, 3 square, 4 square. So 1 by 1 minus x raised to power m, the power will be r raised to power m minus 1, because if you put the value 3, you will get the same sequence here. So when you put r raised to power m here, there will be one term that will be present at the top. So the term will be equal to, it will go from x raised to power 0 plus x raised to power 1 plus x raised to power 2 up to x raised to power m minus 2. Now in previous cases, here m value was 1, so 1 minus 2 will give you nothing, because you cannot put x raised to power minus 1 here. For the next case, x the value of m was 2, so 2 minus 2, x raised to power 0, already settled, because when you put m is equal to 2, you have to go till x raised to power m minus 2. So x raised to power 2 minus 2 will be x raised to power 0, and it is already x raised to power 0, so you don't have to put anything here. But in this case, x raised to power m is equal to 3, so you have to go till x raised to power 3 minus 2, which is equal to x raised to power 1. So you will add nothing but x raised to power 0, which is equal to 1 plus x raised to power 1. So this is the expansion for 1 square, 2 square, 3 square, 4 square and 5 square and so on. And if I told you that, if I ask you expansion for this 1 cube, 2 cube, 3 cube, 4 cube, 5 cube and so on, so you will do nothing but, as you can see, you have to find the cube of natural number. So naturally here it will be 1 raised to power x, 1 minus x raised to power 4, and if it is 4, it will go till x raised to power 1 and x raised to power 2. So this will be the generating function for this sequence. And if you want to I make a little change here, 0 raised to power 3. So it will go from 0, 1 cube, 2 cube, 3 cube. So you will do nothing but you will multiply 1x here in order to make the sequence start from 0. Now let's try some more questions on this. Now the next is, let's say that you have been given a function 1 minus x, 1 by 1 minus x, and it is saying what will be the sequence. So let's say y is equal to 1 minus x given by derivative of y. So it is not asking the sequence for 1 by 1 minus x, because 1 by 1 minus x sequence will be 1 1 1 1 1. So it is asking sequence given by the derivative of y. So if you derive 1 by 1 minus x, you will get what? It is 1 by 1 minus x minus 1. If you derive that differentiation, so 1 minus x square and minus 1 here. So you will get 1 by 1 minus x whole square. So the sequence given by this is nothing but 1 by 1 minus x square. The sequence given will be 1, 2, 3, 4, 5 up to so on. Now let's try another question. It is asking what will be the sequence given by this generating function x raised to power 4, 1 minus x. Now you can solve this very easily. For 1 by 1 minus x, the sequence is given by 1 1 1 1 1, and for x raised to power 4 you will do nothing but put 4 zeros at the start. So these are pretty easy questions here. Now it is asking, now let's try another question. It is asking what will be the series, in power of x will be, what will be the series given by this sequence. So the sequence is 0 0 0 6 comma minus 6 6 comma minus 6 and so on. Now if you want to solve this, first of all 3 zeros are at the start, so x cube will surely be in the function. Now if you take 6 common here, so let's try to solve this way. So we will take 6 common, so 0 0 0 1 minus 1 1 minus 1 and so on. So the function given by this will be x cube will be given by this, and this is 1 minus 1 1 minus 1, so this will be 1 plus x. So this will be the generating function for this sequence. And if you want to expand this further, so 1 plus x is nothing but 1 plus 1 minus x plus x square minus x cube up to so on. And if you multiply this, that sequence, the series that you will get will be 6x cube minus 6x4 plus 6x5 minus 6x6 and so on. So this is the series and this is the generating function for this sequence. Now let's try some other question. Now we will try some past year question that has been asked in the GATE. So those questions are pretty important also. So let's say the question is, they are asking you to find coefficient of x raised to power 12 in x cube, x4 up to so on cube. Now if you take x cube common here, so x9 will come out and you will get what? 1x plus x square plus x cube up to so on. So this is nothing but expansion of 1 by 1 minus x. Now you have to find the coefficient of x raised to power 12 in this, which is pretty easy, because if you do this, sorry, there is a cube here, there is a cube at the top, so we will get 1 minus x cube. So n is equal to 3. Now we know how to solve this. It is pretty easy. N is equal to 3, so 3 minus 1 will be 2 plus r c r x raised to power r. And in this coefficient of x, in order to get the coefficient of x raised to power 12, you have x raised to power 9 here, so r will be equal to what? 3. So if r is equal to 3, the coefficient will be 5c2. Now this was asked in the GATE. So at the time you read this, it may seem that this is a pretty tough question, but if you know how generating function works and how the sequences how to generate the sequences using generating function, and how you can make a generating function using the sequence. You can pretty easily solve these type of questions. Now we have one or two more questions which are quite tricky, so we will try to solve them. Now let's say it is asking what will be the generating function given by this 1 plus x and 1 minus x whole cube. Now there are two methods to solve this. If you see this 1 minus x cube, you can see that it will give you a square root of natural numbers, and if m is equal to 3, the upper value should go till 3 minus 2, which is equal to 1. So we have seen that if m is there, this should go till x1 plus x2 up to xm minus 2. Now m is equal to 3, so if it needs to go till x raised to power 3 minus 2, which is x raised to power 1, so which is already there. So the sequence given by this is, and so on, and the question was find the value of term a3 minus a0. So term a3 minus a0, the term a3 is 4 square and term 0 is 1 square, which is equal to, the answer is 15. Now we were able to solve this because we knew that 1 minus x raised to power m, how to open that and what this signifies. But let's say that you are not able to do that. Again we can solve this with another method. Now the function given to you is 1 by x minus whole cube. You can write it as 1 by 1 minus x cube plus x by 1 minus x whole cube. Now if you solve this generating function, you will get n is equal to 3, so value of n is equal to 3, so 3 minus 1 plus r, which is equal to 2 plus rcr x raised to power r plus x into 2 plus rcr x raised to power r. So this will give you this expression. Now you have to find the value of a3. First you have to find the value of a3, which is nothing but value a3, which is nothing but coefficient of x3. Now in this coefficient of x3, if you want to find, value of r will be equal to nothing but 3. So this is 5c3, and in this coefficient of x raised to power 3 is nothing but, you have x here already, so from r you will require 2. So if it is x square into x will give you x raised to power 3, so r value is equal to 2, so it is 4c2. So this is the value of a3. Now if you solve this, value of a3, 5c3 plus 4c2 will give you 16. And if you want to find out a0, it is nothing but coefficient of x raised to power 0 in this. So for coefficient of x raised to power 0, r value will be 0, so it is nothing but 2c0. Now x is already here, so it will not be giving you x raised to power 0 in any case, so you will not get any coefficient from this. So 2c0 is nothing but 1, so we have to find a3 minus a0, so 16 minus 1 is equal to 15. So here you can see, you can solve this question by any method. You can use any method to solve this by directly opening the generating function, or by expanding the generating function, which is a pretty basic method which you learn at the start. That method, the first one that we used, was a more advanced method where you didn't open the generating function by using the chocolate property. You just knew that this will be the expansion of this generating function. Now let's try one more question. Now the next question is, you have been given a sequence an is equal to 2n plus 3, and it is saying that what will be the generating function for this one. It is a sequence. Now let's try to open this sequence. So when n value will be equal to 0, it will be 3, then 5, then 7, then 9, and so on. Now if you want to solve this, you have to divide this into two parts. So it is nothing but 3 plus 0, because n was 0 here, 3 plus 2 into 1, because 2n, so we will be taking 2 raised to 2 into 1, 2 into 2, 2 into 3, 3 plus 2 into 2, 3 plus 2 into 3, up to so on. Now this will, you can see that this whole sequence we can divide into two parts. First part is, it will have 3, 3, 3, 3, 3 at every step, 3, 3, 3, 3, 3 at every step, and the next part is plus 2 into 0, 2 into 1, 2 into 2, 2 into 3 up to so on. If you expand this further and take some things common out of it, if you take 3 out common out of it, it will give you 1, 1, 1, 1, 1 up to so on. And if you take 2 common out of it, it will give you 0, 1, 2, 3 up to 4 and so on, 0. Now if you can see 1, 1, 1, it is the expansion of nothing but 1 minus x. Here you are starting with 0, so 1x will come here. Now this is nothing but 1, 2, 3, 4. It is a sequence of natural numbers, and we have seen the sequence for natural numbers is nothing but 1 minus x whole square. So if you solve this further, it will give you 3 into 1 minus x plus 2x over 1 minus x whole square. So the generating function will be 3 minus x over 1 minus x whole square. So this is the generating function for the given an that was given initially to us. So the generating function will be 3 minus x over 1 minus x whole square. So this is so today in this video we learn how to solve, how to find the number of solutions for any equations in which constraints have been given to you by using generating function. We have seen how to solve the generating function by expanding the constraints using chocolate property. Then we have seen how you can get a sequence from a generating function, how to find the sequence that will be obtained by the generating function. Then we saw a variety of generating function, that if you do this change in the variety in the generating function, how it will affect the given sequence. Then we saw how you can obtain a generating function from the sequence. So first we saw getting a sequence from the generating function, then we saw getting a generating function from the sequence. So this is a pretty important concept, and panelists have been asking questions from the generating function in the DRDO interview. So it is pretty important. So I hope you understood the concept of generating function. So keep watching and keep preparing. Thank you.